Good afternoon, class, and welcome to my first attempt at a digital lesson. I thank you for joining me, and hopefully it will go somewhat smoothly. Hopefully I will soon be in a regular classroom with all of you. So as I mentioned, today's lesson is going to be on dimensional analysis. And different teachers call it different things. When I was in school, we called it dimensional analysis. Other science teachers, you really get into this more even in science than in math, although they are super related to each other. It's really just a process of converting units. For example, converting inches to feet, feet into yards, meters into millimeters. But then we also sometimes will have some crossing of the units. For example, kilograms with pounds, metric system versus our SI system. Or we might have inches and we want to change that into meters. All right, where that's maybe not a nice, as easy, smooth conversion. So before we start anything, I want to just do a quick little refresher about the behavior of units. And when we talk about units, and we've seen this before, when we add units versus multiplying units, we really have two different results. And it's really the basis for why dimensional analysis is important and how it works. All right, so if we're talking about the addition of units, if we go to the most basic that you would have done back in elementary school, such as adding 2 apples and 3 apples together, I'm sure we would all agree that we end up with 5 apples. Now, the point of this is that the units do not change. Apples added to apples remain apples. And that's a little different than when we deal with multiplication. For example, and we've dealt with this before, if you have a rectangle and we want to find the area, and maybe our dimensions are 10 meters by 15 meters. If I were to calculate the area of this, we would do 10 meters times 15 meters. Well, 10 times 15 is 150. Meters times meters, what do we always say about units for area? It's always square meters. This is why. Because meters times meters will give me meters squared. So this is important because moving forward, when we look at dimensional analysis, we are going to want to eliminate certain units. And to eliminate certain units, we're not going to want to multiply them, because as you can see, meters times meters does not eliminate meters. We are going to want to divide them in order for us to get rid of them, to actually change units from maybe meters into centimeters or something else. So let's take a look at our note sheet. So there are some relationships they do expect you to know. There's 12 inches in a foot, 10 millimeters in a centimeter, 60 seconds in a minute, 3 feet in a yard, 100 centimeters in a meter. Remember, this is why the metric system is nice. Centi, the prefix, is telling me it's the prefix for 100. That's why we know there's 100. 60 minutes in an hour. 5,280 feet in a mile. They do give this to you on the reference sheet. It's still good to know. 1,000 meters in a kilometer. Again, kilo, 1,000. So 1,000 meters in a kilometer. 24 hours in a day. The state does give us a list of conversions on our reference sheet. This is the same reference sheet that you've been given last year on the algebra exam. You'll see it this year on the geometry exam, and you'll see it next year on the Algebra 2 exam. It's the same reference sheet. So you can see there's quite a few different ones, and a lot of them are really based on switching from SI into metric or vice versa. There's a little bit here that's within the same SI system, but the majority of it is switching systems. So how do you do dimensional analysis? Well, there's essentially a pattern. We start with the number of units that you currently have. If it's not currently a fraction, you can put it over 1. Sometimes it will be a fraction, for example, miles per hour, mph. That's miles in the numerator. Per means over hours. So sometimes you'll have a fraction, sometimes you won't. If you don't have a fraction, you might want to put a 1 in the denominator. But really, it's our second piece that's the most important. We're going to, since the units you have is in our numerator, remember we said in order to eliminate the units, we're going to want to divide. And so therefore, in our denominator, we're going to want to have the units you have. And the units that we want is going to end up being in the numerator. All right, so let's look at our first example. Just scoot this here for a second. So here we want to convert 4.5 kilometers into millimeters. So we're going to use the conversion that 1 kilometer is equal to 1 million millimeters. So again, 4.5 kilometers, it is not currently a fraction. So I'm going to put it over 1. And here's the most important piece. We want to make sure that we set up our conversion ratio, our conversion fraction, so that if kilometers is in the numerator, in order to eliminate it, we want kilometers in the denominator. So 1 kilometer, there are 1 million millimeters. Notice millimeters is our numerator. Now, remember, when we multiply fractions, it's numerator times numerator over denominator times denominator. Since kilometers will reduce, we have 1 on the top, 1 on the bottom, 1 in the numerator, 1 in the denominator. We will be left with millimeters, and we get 4.5 million millimeters. So let's look at our next example. Here we are, now this is a little bit harder, a little bit more challenging. Here we want to convert from miles per hour to feet per second. So we basically are doing two conversions. We're converting length or distance from miles into feet, but then we're also converting time, hours into seconds. So there's two conversions going on here. Here's an example, miles per hour. Per means over. So here's an example where we actually do have a fraction. So there are 65 miles over 1 hour. Now, I'm going to break this down and I'm going to eliminate the miles first. We'll work with that, and then we'll deal with the hours second. So let's start with the miles. So again, our conversion ratio. Since miles is in our numerator, we want miles in the denominator. And the units we want go in the numerator, feet. So miles in the numerator, miles in the denominator, they will cancel, and I'm left with feet. So there are 5,280 feet in 1 mile. So I've taken care of the conversion of our distance. Now I need to deal with the conversion of time. We want to go from hours to seconds, but there is not a direct jump between hours and seconds. So what's our intermediate step? We need to deal with minutes. So I'm going to start out. Now notice, if hours is on the denominator, the bottom, if we want to eliminate hours, it's got to be in the numerator this time. So you've got it in the bottom and you've got it on the top. And we're going to convert with minutes. In 1 hour, there are 60 minutes. So hour on the bottom, hour on the top, minutes on the bottom. Hours cancel. But now I need to switch from minutes into seconds. If minutes are on the bottom, then I need minutes on the top. We want to make sure that we are able to cancel. So a denominator and a numerator are necessary. And since seconds ultimately will need to be on the bottom, we have 60 seconds. Then it's just a matter of multiplying numerators together, denominators together, and we end up with 343,200 feet over 3,600 seconds. Or if we want to convert it so that it's a unit, 1 second per second, not per 3,600 seconds, we divide and we end up with 95.3 feet per second. Or you could write it out in words, 95.3 feet per second. Our third example is really dealing with conversion of yards to centimeters. So now we're switching from SI into metric. So again, we're going to use the fact there are 0.914 meters in a yard. So again, now this time we do not already have a fraction, so I put it over 1. And we're going to use the fact that yards on the top, yards on the bottom. We want to make sure we have 1 in the numerator, 1 in the denominator. They will cancel. Then we had to switch from meters into centimeters. So meters in the numerator, we need meters in the denominator, and centimeters, 100 centimeters in 1 meter. Okay. And I have one more example that I finished, and then we're going to take a look at a few different other examples. So, how many miles will a person walk in a 10-kilometer race? Walk, run, it doesn't matter. So again, 10 kilometers. And again, if you want to, you can always put that over 1. So I'm going to reference my reference sheet. All right. So what's the relationship between kilometers and miles? 1 kilometer is 0.62 miles. So kilometer in the numerator, so I need kilometer in the denominator. Miles is what I want, so it goes in the numerator. So kilometer reduces with kilometer. We multiply our numerators together, we multiply our denominators together, and I'm left with 6.2 miles. So let's take a look at our next example, example 2. A student is in class 330 minutes per day. How many hours per day would this be? So the day part is okay. We need to convert, though, the minutes into hours. So let's think about this for a second. If minutes is currently in the numerator, then for me to get rid of it and to eliminate it or reduce it, minutes will need to be in the denominator. So I have 1 on the top and 1 on the bottom. That will allow me to cancel or reduce. Per day is fine. All right, but now I need to convert into hours. So hours is what we want. Let's put it in the numerator. So in 1 hour, there are 60 minutes. So our minutes will reduce with minutes. That's looking good. It's leaving me with hours in the numerator, days in the denominator. That'll be hours per day. So we multiply 330 hours, 1 times 60, 60 days. Okay, but I want to find out what it is per day. So now I'm going to take my calculator and I'm going to divide 330 divided by 60. So we end up with 5.5 hours per 1 day, or 5.5 hours, and you could write the word per day. Okay. All right. Let's look at our next one. Question 3. The moon is approximately 25,000 miles from Earth. How many feet is it from the Earth to the moon? So again, we're going to start out 25,000 miles over 1. So I like to have a fraction, times. Now, we need to do a conversion from miles into feet. So we're going from miles into feet. So I think the most logical thing is to use the 5,280 feet per mile. So since miles are in the numerator, I need miles in the denominator. And since feet is what we want, it goes in the numerator. So we're going to use 5,280 feet per 1 mile. Now this is nice because miles will reduce with miles. And then I can go ahead and multiply. So 250,000 gives me, a very big number. Let's see here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're looking at, huge number. 1,320,000,000 feet. Huge number. Huge number. All right, let's do another one. How many minutes are in 180 days? So again, 180 days is what we're converting. I'll put it over 1. Now, ultimately, we want to end up with minutes in the end, but I don't think there's going to be a real quick conversion from minutes and days. So we're going to have to do some intermediate things. So let's start out with days. All right, days is in the numerator. So I need days in the denominator. So I think to myself, well, what conversions do we know? Well, we know hours. We know that there are 24 hours for every 1 day. So days will cancel with days. That looks good to me. But we're still not quite there yet. We need to get rid of hours. So let's put that in the denominator. And let's see here. Well, in 24 hours. So let's see. We know that every hour has 60 minutes. So let's put 60 minutes in the numerator and 1 hour in the denominator. And that will allow hours to reduce. And notice, in my numerator, I end up with the units ultimately I wanted, which were minutes. So now I can just go ahead and do a little multiplication. Numerator times numerator, denominator times denominator. And we end up with 259,200 minutes. Okay. So now we're moving into some more interesting ones. A pool holds 10,000 gallons of water. How many cubic centimeters is this? So let's start. So we've got 10,000 gallons. And we're going to multiply. So I need a conversion. I need a conversion that converts gallons into cubic centimeters. So let's see what we've got. And again, it may not be a direct conversion. So let's look at what we've got here. We've got gallons and quarts, gallons and liters, and then we've got liters and cubic centimeters. Now, ultimately, I'm trying to get to cubic centimeters. So I'm first going to have to convert from gallons into liters so that I can then convert from liters into cubic centimeters. So we're going to do our conversion of gallons into liters. So since gallons is currently in my numerator, we want gallons in the denominator. So I'm going to use the conversion from my sheet. In 1 gallon, there are 3.785 liters. Okay. So again, gallon in the numerator, I can put that over 1 if we'd like. And that will cancel or eliminate our gallons. Next, we're going to do our conversion for liters. We want to go liters into cubic centimeters. And again, I'm using 1 liter equals 1,000 cubic centimeters. So liters on the denominator, cubic centimeters in our numerator. So 1 liter is 1,000 cubic centimeters. Liter cancels with liters. So notice what I'm left with. In my numerator, I am left with cubic centimeters, which is ultimately what we wanted our units to be. So we multiply numerator times numerator. So 10,000 times 3.785 times 1,000. gives me again a pretty big number. We're looking at over 3,785,000. Oh my gosh, I just put my comma in the wrong spot. Let me go ahead and fix that. 37,850,000 cubic centimeters. Okay. In our next example, we're going to convert from driving 60 miles per hour into feet per second. So here we're dealing with two different conversions. We're converting from miles into feet, and we're converting from hours into seconds. So we have two different conversions. I recommend doing one conversion at a time rather than trying to do everything all at once. So let's start. 60 miles per means over 1 hour. I'm going to start with my conversion of miles into feet. So again, if miles are my numerator, miles will be in the denominator. And we'll use feet. So there's 5,280 feet in 1 mile. All right. So that's going to allow me to reduce miles. Now I need to get rid of hours. I need to convert that into seconds. Now, because hours is in my denominator, hours will now need to be in my numerator. And we're going to want seconds, okay, in our denominator. Well, in 1 hour, there are, not seconds. I think we're going to have to do minutes first. So we're going to do 60 minutes per 1 hour, and we're going to have to do one more conversion. There's 1 minute, 60 seconds. And so now hours cancels with hours, minutes with minutes, and we're going to be left with 60 times 5280 divided by 3,600, and we're left with 88 feet per second. Okay. Go ahead and try the other examples. I will do the workout and post the notes online. Tonight's homework, of course, is a worksheet, and answers will be posted. And if there's any questions, please send me an email and ask the question. I will happily answer. I hope everyone is fine, and I will hopefully see you very soon. Take care.